So I'm sure you can see the grade on at the corner of this worksheet. So we are enlisting the grade 9s onto this live, guys. Grade 9s, grade 9s, grade 9s. Oh, grade 8 and grade 9 are so much the same. You should just stick around for this grade 9 session because the grade 8 and 9s are so like the same. There's no difference. Grade 8 and grade 9 are so like the same. Alright, welcome to the grade 9s that are joining in the live. I hope you guys are good. It's been a minute. It's been a minute and a bit. I'm hoping that the connection is not failing or fading, but let me know in the comment section how the connection is, like how's the connectivity with everyone. Let me know if it's bad, let me know if it's not great, so that I can be able to see what I can do. Anything that I can do that's within my power to do, I'll try and do. But if I can't do anything that can be done, then I won't do anything that can be done. Alright, so from what I'm seeing right now, what is it saying? It's saying unstable connection. Alright, I'll stick around to catch something. Just vibes, you're killing me. Just vibes, like I'll stick around to see if I can catch something. Okay. Yeah. Let's see if I can't share this live with other grade 9s. Just wait a sec. Let me see if I can't share this with some. Okay, yeah, please guys, if you can and it is feasible for you to do so, share the live with people that might need it, the grade 9s, okay? Because what I'm doing right now is I'm doing a bit of grade 9 revision for the June exams, okay? Yeah, so I'm just diving into, you know, a lot of like variety of things that you ought to know for grade 9. So let's look at the first question, and we'll take this question paper one bit at a time. We'll answer some of the questions. Please utilize the comment section to also assist in being able to answer some of the questions. The more vibrant and more participative you'll be, the better it will be for you. So the first question says, consider the expression. Now guys, hopefully by now this term you guys have learned what I would call polynomials, right? An expression with more than one term. All right, and there are different types of polynomials. We have monomials, one term. We've got binomials, 2 terms. We've got trinomials, 3 terms, and so the list is endless. So here we have 3x squared minus x cubed plus 1 over 2x minus 3, and the question is saying how many terms are there in the expression for one single mark. So what do you guys say? How many terms are there in this expression? I am not going to write the answer until you tell me. Look at Just Vibes. Just Vibes says there are 4 terms. What does everybody else say? I will move on to the next question when I have more than 3 answers in the comment section that are correct. And if there be someone that deviates from the actual answer, then of course I will fix whatever needs to be fixed. Okay, we've got Tabata and we've got Yummy Always Hungry. Oh, yummy. And the hot. Okay, guys, I see. Mini Mini, I see as well. Hello, Mini. I see as well. So how many terms are there in the expression? You guys are 100% correct. There are 4 terms. And what I love is that in the comment section, no one deviated and answered something that's incorrect. So that means you guys all know that terms are separated by a plus and a minus sign. Grade 9, grade 9, grade 9. This is grade 9. Okay, next question. Give the degree of the expression for 1 mark. Okay, so let me know in the comment section, what is the degree of the expression? Okay, just vibes just answered. I see just vibes. I see you there. The degree of the expression. Okay, I see user 21997 as well. Yummy, always hungry, always hungry. Simvuyele Mkef, I see there as well. Rakhoto as well. Okay, so we have more than 3 answers from 4 different people, and they have all answered correctly. So the degree of the expression, yes indeed, the degree of the expression, guys, when you write the answer for this, okay, you can either say it's the 3rd degree, or you can say degree is 3. All right, yes. What is the degree of the expression? The degree of the expression is the highest exponent that exists for your terms. So if you look at the variable x, this is x squared, x cubed, x. So x is the main character variable, and which term's variable has the highest exponent? It is the 2nd term. It's x to the power 3. So this here, the term that has the variable with the highest exponent is what we refer to as the degree of the expression. So you guys are 100% correct. Please guys, you either write 3rd degree, or you can say the degree is 3, or you can simply write 3, you know. So these are like 3 different ways of actually writing the same answer for this question. Okay, let's move on to the next question. Give the constant value of the expression. The constant value of the expression. The constant value of the expression. So there's your expression. The constant value is, okay, you can see the answer. Just Vibes gave us an answer. Daimani says, give us an answer. Yami, Tlotleho, Simvuyele, Just Vibes. Okay. So once again, we have more than 3 people that have given us the correct answer. Just a bit concerned there from Just Vibes. Just Vibes says 3. All right. So okay, and Just Vibes says -2. Okay, let's be careful there. Right? Remember, what is a constant value of the expression, or constant term? Constant term is the term that has no variable. The term that has no variable, and by variable we mean a term that has no letter of the alphabet next to it. So 3x squared definitely has the variable, x cubed has a variable, half x has a variable, -3 does not have a variable. So the term that has no variable or letter of the alphabet is what we refer to as the constant value of the expression. So let's note that when we write that constant value, we don't only write the number, but we write the sign of the number as well. Okay, no problem, Just Vibes, no problem. Okay, I reckon that I am actually teaching some of the best in the country. Like, people are just answering correctly here. So great. Yeah, so the constant value of the expression is -3. We make sure that the sign tags along with the number. We don't just write the number, but we make sure that the sign preceding the number tags along, and we indicate that as the constant value. Okay, let's go ahead now. The next question. Give the coefficient of x. Give the coefficient of x. This word, coefficient. The coefficient of x. Okay, I see Yami always hungry is there. He's got an answer. Yes, Rahot, definitely. Mini de Tlotleho, Simvuyele. All right, okay. And yes, Rahot, you're definitely going to find this there. Hopefully they don't give me problems this TikTok. Lately TikTok does not seem to download your videos. It's very, it's been giving me some problems there, but hopefully it will work out this time around. Okay, so definitely guys, This is a grade 8 and grade 9 relevant lesson, okay? Grade 8 and grade 9. Yes, it's grade 9, but grade 8 and 9, you will know that largely much of the content is very similar. So the coefficient of x, guys, the coefficient of x, definitely here is the term that has x. Okay, this one has x cubed, so we're not looking at this one. This one has x squared. We are not looking at this term. We're looking at the one that has x, just the variable x. So the coefficient, what is a coefficient? The coefficient is everything that stands next to that specific variable that we are talking about. So here, what is standing next to the variable x? What is standing next to the variable x? What is combined with the variable x? What is multiplied to the variable x is a half, and it's positive half. So it's definitely, like you guys have said, the coefficient is half, 100%. Okay, 100%. You guys are doing so nicely there in the comment section. I see you guys know your work very well. Okay, now what if I ask the question, what is the coefficient of x cubed? What if the question was saying, what is the coefficient of x cubed? What would you guys say? What would be the answer? The coefficient of x cubed. Okay, I see Just Vibes there. I see Just Vibes, what you've written down. Nuri there, I see you as well. Rachot, I see what you're saying there as well. Okay, Rahoto changes his answer. Jaden, I see you there as well. Tlotlech, I see your answer too. Nolukholo Mfana, I see you there. TD, I see your answer. And Mini Simbuyele Ongeziwe. Okay, please take note, guys. The coefficient of x cubed. So we are looking at this term, the second term here. The coefficient, so looking at what is standing next to x cubed. What is standing next to x cubed and is combined to x cubed is -1. Please, guys. There's a negative, but remember there's a invisible one that is there, all right, that we cannot see, but it's ever present. So we say that the coefficient of x cubed, we would say -1. If the question was asked, we would say -1. Okay, all right. I just wanna do one last thing here. Let's say I had another term and it was plus 7x qx to the power 4y. All right, and then I asked the question, let's say that there were 5 terms, okay, and there was a term that was plus 7x to the power 4y, and I asked you guys, what is the coefficient of x to the power 4? What is the coefficient of x to the power 4? What would you guys answer? What is the coefficient of x to the power 4? What is the coefficient of x to the power 4? What is the coefficient of x to the power 4? I feel like the answer will shock you guys, okay? What is the coefficient of x to the power 4? Yo, all right. Yeah. Tabata 7 is what I call my hero. Tabata 7. Tabata 7, Likona CD. You guys are my hero. What is the coefficient of x to the power 4? What would your answer be, guys? Okay, so I see everybody who's writing down their answer. Okay, so what is the coefficient of x to the power 4? That was my question. Okay, so remember now, let's look at the answer. So if we are looking at the coefficient of x to the power 4, we are looking at which term? We are looking at this particular term. This term has the x to the power 4 that we are referring to. What is the coefficient of x to the power 4? Guys, the coefficient of x to the power 4 will be 7. The 7, which is positive, of course, but it would be 7y. 7y. Now, this is something that I want you to all note in the live session that you are currently in. Okay, please, guys, right? The coefficient, remember what I said in my definition of the coefficient. I said that the coefficient would be whatever combined to the specific variable that we are referring to. So I said to you guys, what is the coefficient of x to the power 4? Now, what is combined to x to the power 4? It is not only 7, but it is also the y. Remember, y stands in the place of something that we do not know. So when we are referring to the coefficient, we are referring to everything that is combined to x to the power 4. So the coefficient would be positive 7y. That would be the coefficient of x to the power 4. And I want you guys to note that, because it is extremely important. Most of you would have probably said the answer is 7, and that is coming from the idea that the coefficient is the numerical value that is next to the variable that you are talking about. But the thing is, y here is standing in the place of an unknown number, all right? So therefore, if you are going to specify what is the coefficient of x to the power 4, then you would have to conclude that it is not only just 7, but it is positive 7y that is the coefficient of x to the power 4. So I hope that adds a bit of a new dimension to your understanding of what a coefficient is, because that understanding, guys, is very crucial and important. Most people lose their marks whenever they are asked this particular question: what is the coefficient of x to the power 4? Because most people have in their heads this idea that it is only just 7. But the thing is, if you are specifying what is the coefficient of x to the power 4, you would also have to consider this y, which is also combined to the x to the power 4. Right? Remember that the relationship between positive 7, x to the power 4, and y is one of multiplication, and that's what combines 7x to the power 4y to become 1. But what is the coefficient? It is 7y, and it's positive 7y. So let's move on. Right? Hopefully you can grasp that and you'll never forget it. The next question, 1.5, says calculate the value of the expression if x is equal to negative 2. Calculate the value of the expression if x is equal to negative 2. So I want you guys to just don't consider, just forget about this, because remember I just added that. Why did I add it? I added it because I wanted to actually just teach something important. Okay, so we're looking at just this 1, 2, 3, 4 terms, and we want to know what is the value. Calculate the value of the expression if x is equal to negative 2 for this expression. So what would be the value of the expression? Okay, right, so I'm going to give you just I think 2 minutes would be good for you guys to sort of like write down, do your calculations, and then I will answer it. You guys can use the comment section the minute you are able to get your respective answers. Calculate the value of the expression if x is equal to negative 2 for this expression. The value of x, okay, the value, sorry, of the expression if x is equal to negative 2. So this is the expression, and they want to know what the value of the expression is if x is equal to negative 2. The value of the expression if x is equal to negative 2. Okay, in the comment section there's someone who's saying we need to sub the minus 2 into the x. Definitely correct, definitely true. Okay, and then after having done that, what is the glorious value that you guys get? Kate City says she is getting a 16 as the value of the expression. What is everybody else getting as they do the calculation? Minnie also got 16. Okay, because it seems like there's some concession around the number 16. 2 people have got 16. Mosima Letabo says 16 as well. Tlotlego says negative 18. All right, very interesting. Simvuyele says, I also got 16. Okay, so there's 3 people now, more than 3 people who have gotten the same answer. All right, so let's just check it quickly. Let's go and write down the expression and substitute negative 2. And remember, guys, when we substitute the negative 2 in the place of x, we make sure that we substitute using brackets. Please, in the place of x, we write the negative 2 minus, in the place of x, negative 2 plus half. In the place of x, we write negative 2, negative 3. All right, so this is very important that you need to write this out and make sure that you do it while substituting in the place of x negative 2. That's very important for your grade 8s and 9s. When you answer this question, you need to substitute using those brackets. Very important. Then the exponent 2, when it is applied to a negative sign, we all know that the negative sign, what happens? It becomes positive. And then 2 squared is actually 4. So we have 3 times 4 here minus this negative 2 to the power 3. Remember, the exponent applied to the negative sign, it remains negative. And then obviously this is negative 8 plus. Okay, now obviously the half and the negative 2, you can actually multiply. You get a nice negative 1 with a negative 3. Why am I doing all of this? It's because BEDMAS requires me to do that. Remember, BEDMAS says brackets. You start with your brackets. Okay, so whatever is in the brackets you look at, and then you apply after that e, meaning you apply your exponents to what is in the brackets. That gets priority. So that's why I checked the exponent 2. When the exponent 2 is applied to a negative sign, it becomes positive, and then 2 to the power 2 becomes 4. So that's why I have 4 inside this bracket. The exponent 3 is odd. When you apply an odd exponent to a negative sign, it becomes negative, but then 2 to the power 3 is 8. Here there is an exponent 1, does not have much of an effect on the negative 2, so half times negative 2 can be multiplied just like that. We get negative 1, and that's minus 3. So you have 12, negative times a negative, it's plus 8, positive times a negative is negative 1, minus 3. Now guys, 12 plus 8 is 20, right? 12 plus 8 is 20, minus 1 is 19. 19 minus 3 is 16. So all those beautiful people that said the answer is 16, you guys are amazing. You guys are absolutely phenomenal. All right, you guys are amazing, kabazing. Like, yeah, you guys deserve, I don't know, like something amazing. So if you were able to answer this question, consider the expression. You were able to answer these questions 100% correct, including the additional questions that I asked pertaining to the coefficient of other variables, then you guys are phenomenal. Okay, so please guys, let's make sure that these types of questions, these polynomial questions, you did them in grade 8. All right, you are in grade 9 now, you are doing them for the second time, so you should be people now that just do amazing stuff. Okay, so itumeleng stumza, just for you, how did you do 1.1.2? The 1.1.2 says give the degree of the expression. What does degree of the expression mean? The term or the concept degree of the expression means the variable with the highest exponent. So what you want to do is you want to go to your expression, look at the term that has the variable. Remember, what is a variable? The variable is simply the letter of the alphabet in your terms. So you have x squared, that's the main character variable, x. But look at the one that has the highest exponent. Which variable has the highest exponent? It is x to the power 3. So therefore, this here is your degree. All right, so that's why we say the degree of the expression is, we can either say it's the third degree, or we can say the degree is 3, or we can just simply write the number 3. All right, so that is what we call the degree of the expression. So that's how we did 1.1.2. So hopefully that helps you a lot. Let's go to 1.2, guys. 1.2. So my grade 8s that are here should be loving this, because this is definitely pertaining to what they are doing in algebraic expressions, grade 9, of course. This is a good revision for you, and you are doing this as well. So it says add the following: 3x squared minus 7x minus 9 with x squared plus 3x plus 15 and 4 minus x squared. You need to add these. So you have this expression, you need to add it to this expression, you need to add it to that expression. Okay, so if we are adding, then of course, what does that mean? It just means we are taking all of these: 3x squared minus 7x minus 9. We add x squared plus 3x plus 15, and we add 4 minus x squared. So in a way, you could say that we can put these respective expressions in brackets. Okay, and then remember this plus sign. Okay, when we look at this plus sign, yes, we do. When looking for the degree of the expression, we consider the variables. Very important, very important, considering the variable, the main character variable in that case, which is x. So we look at that. Okay, so if we write down this expression, 3x squared minus 7x minus 9, it says add. That's the instruction. So remember, what does add mean? It means that we need to add all of these three expressions together. Okay, yes, Mini, very true. We need to gather the like terms. All right, but before we do that, please note something, that if you are doing this, you need to make sure that you understand that these expressions, all right, are sort of like in brackets, and the way you would remove the bracket, because there's a plus sign, the plus sign does not affect what's inside each expression. All right, so that's why it's easy to just simply do what? We can just simply add the like terms. So we can gather the like terms. We have 3x squared, which is positive. We add it to x squared. Okay, and then after that, the positive times the negative still retains the negative x squared. Do you see that, guys? Okay, because remember, the x squared here is negative, but you see the addition sign. If you distribute the addition sign inside this bracket, it still keeps that negative sign negative. So that's why when you collect the like terms, it's 3x squared plus x squared minus x squared. That's why I'm emphasizing this point, that these expressions, when you adding them, you need to remember that the addition sign that precedes each expression will not affect what's inside the terms, which is very important. So the signs will still remain the same because it's addition. Okay, so now we can collect the like terms, because we know this addition sign is not going to affect anything that's in the expression. So we collect the like terms. It's 3x squared plus this x squared, but we say minus this x squared because a positive times a negative still gives us a negative. Then we have negative 7x plus the 3x plus the 4. Okay, and then lastly, plus the 3x plus the 4, and then this constant term is negative 9 plus the 15. So obviously, if you add the like terms of x squared, what's 3x squared plus x squared minus x squared? Remember, when we are adding like terms, the variable stays the same. So x squared will stay the same, it doesn't change. But what changes, or what do we add? We add the coefficient. So 3 plus 1, there's a 1 before this x squared. 3 plus 1 is 4, and then 4 minus the 1 is actually equal to 3. Okay, let's move on to the x term. Our x terms. Negative 7 plus 3x. Remember, we keep the variable, and then what's negative 7 plus 3? It is negative 4. Okay, Msawengos Indlo over there has got it down in the comment section. Msawengos is like on the money there, like, you know, commented 3 times in a row to comment the true answer. And then lastly, our constant terms. What's 4 minus 9? 4 minus 9 is negative 5. Then negative 5 plus 15 gives us positive 10. So there it is. That is indeed the answer, as Msawenko Sindlovu has indicated in the comment section. So please, grade 9s, grade 8s, this is very important that when you are given expressions to add, note that yes, the expressions can be added, right? What follows as your second expression, preceded by a plus sign, will not affect the three terms. Right? So that's why when we are adding, we say 3x squared plus this x squared, but we say minus this x squared because the positive times the negative still retains the negative sign of the x squared. Okay? All right? Then it's like everything else is sort of like also the same. With the x terms, minus 7x, that still retains its sign, plus 3x, all right? And then the constant terms, negative 9 plus 15 plus 4. And then when you finally add these, you actually get 3x squared minus 4x plus 10. All right, so yeah, so let's take note of that. Then 1.3. Walid, I'll attend to you just now. You are talking about 1.1.2, the degree of the expression. I'll get back to that just shortly, okay? Subtract 7x squared minus 3x minus 4 from. Now, please, guys, the wording here is very important. It's saying subtract this from that. So which expression are we going to write first? Are we going to write this expression first, or are we going to write this expression first? Which one, guys? Is it the second expression is it the first expression that we write first, or is it the second expression that we write first? Because it's saying subtract this from that. Okay, so we are going to, obviously, when we write down, yes, we're going to write the second one first. So we are going to write negative 2x squared plus 5x minus 7. Now, please, guys, take note of the following. So we are going to write this first, because if we are subtracting this from, then we need to write this one first and then say minus. Please take note, guys. I'm going to write my brackets. Okay, and this is very important. I write my brackets, okay, after the negative sign, right? Then this negative sign needs to be distributed to my three terms. Very, very important, before I gather my like terms, right? So what I'm now going to have is negative 2x squared plus 5x, obviously, minus my 7. But take note what happens here. Negative times a positive 7x squared gives me a negative 7x squared. Negative times a negative 3x gives me a positive 3x. And then lastly, negative times a negative 4 gives me a positive 4. And guys, if I don't do this, there becomes big problems. Okay? Very, very important that first and foremost, the interpretation of what I read here, because some people can simply say 7x squared minus 3x minus 4 minus this. No. This thing is saying subtract this from. So that means he must start, as we've written him down as the first expression, and then we subtract that. But when we subtract this, we must put it in brackets, and then we must make sure that this negative sign is distributed to each term. We must multiply the negative with the 7x squared, we get negative 7x squared. Multiply the negative with the negative 3x, get positive 3x. And then multiply the negative with the negative 4, get positive 4. Okay, this is very important, that part. If we don't do that part, what happens is that we simply think that this negative sign is only attached to 7x squared, and then we butcher the question completely. Okay, so make sure. Now we can gather like terms. So the negative 2x squared with the negative 7x squared. You see that the signs are retained. The plus positive 5x with the positive 3x. The negative 7 with the positive 4. You see? Then when we add like terms, guys, it's so easy. We keep the variable x squared. So it's like the the uniform of that particular school stays the same. So x squared stays the same. And then the number -2, -7 gives us -9. Guys, if we are failing to be able to add and subtract these coefficients, let's use our calculator. If you punch into your calculator -2, -2 minus 7, it will give you the answer -9. So let us not take for granted that we are fluent in our addition and our subtraction in our heads. If our heads are not working nice, calculator is there for that purpose. You take your calculator, you put in -2 minus 7, you'll get the -9. Please guys, we don't want to be losing marks simply because we did not add and subtract the coefficients correctly. The next two terms, 5x plus 3x, we keep the variable x, it does not change. Then 5 plus 3, positive 5 plus 3 gives us positive 8. And then lastly, -7 plus 4. Okay, like I said, if you guys know that you're gonna mess this up, calculator, please guys, you have the liberty of using it. -7 plus 4 gives you -3. Right? So who are my beautiful people in the comment section that got them? Sawenkosi got it, Itumeleng got it, Kanya got it, I see even Mini had agreed with Kanya as well. Okay, so that's beautiful, and I'm very happy guys that we are all getting this very nicely. Simvuel has also got it nicely. So let's just go back a little bit to Walid. Walid was asking, how do we answer this question 1.1.2? Give the degree of the expression. So Walid, this was our expression, 3x squared minus x cubed plus half x minus 3. So when we looked at this expression, when we want the degree of the expression, what are we looking at? We are looking at the variable with the highest exponent. So if you come here, what is a variable? Variable is simply the letter of the alphabet in our expression. The letter of the alphabet here, which is predominant, is x, x, x. That is the variable. Now we want to locate which one has the highest exponent. So we look at, this is x squared, this is x cubed, this is x to the power. We know that there's a 1 there that's invisible. So which one has the highest exponent? It's x to the power 3. Okay, this is the term variable that has the highest exponent. So because the highest exponent is 3, we then say that the degree of the expression is, we can either write the answer in this way, third degree, or we can say the degree is 3, or we can say it is 3. All right, so one of 3 ways to actually write the answer. You choose which way is more palatable to you, and you utilize that way consistently throughout whenever you're asked such questions. Okay, moving right along guys. Hey, we're moving very nicely, and I'm hoping people are good and they are feeling this. So can I ask you questions about your maths teaching online after this session? Yes, CD, you are more than welcome. You can ask away. You can send me a DM even on TikTok, and we can chat further. Okay, let's look at this question. Guys, I'm sorry, my kids are having a heck of a good time in and around with the vicinity. I hope the noise is not too disruptive that it takes your attention away from what I'm doing, but I also want them to sort of like enjoy their time. I don't want to be that kind of guy who says, you guys keep quiet because I'm busy here. No. All right, simplify the following. -13x into 3x squared minus 8x minus 9. Now, I'm sure you guys now have been doing how to multiply monomials, right? Monomials. This here is a -13x, all right? It is external to the bracket. Brackets in mathematics mean multiply. Inside the bracket, we have how many terms? We have 1, 2, 3 terms. But the minute those terms are inside a bracket, we say that there is 1 term. Okay, so -13x into 3x squared minus 8x minus 9. We are required to simplify the following. So what we know we can take as an instruction from this is that we need to take -13x. Because there's a bracket, this -13x needs to be distributed to the 3 terms. So D stands for distributive. distribution law, and the L stands for law. So we apply the distribution law, considering something very important that I like talking about, which is what we usually see in the movies, SNL. SNL. S stands for we distribute the sign, we distribute the number, and then we distribute the letter, or in this case, the variable. So I'm just saying, for those who are tuning into my live for the very first time and they're like, what in the world is this guy talking about? So the distributive law is the way in which we take this 13x, because brackets mean multiply, we are going to distribute the negative 13x and multiply it with the 3x squared. But when we do that, we must consider the multiplication first of the sign, followed by the multiplication of the number, followed by the multiplication of the letter. If we do that consistently, then there is no way we'll make an error here. So check this out. This 13x is negative. This 3x squared is positive. So in my head, the first thing I ask myself, what is for the sign as I am distributing, what is a positive? Negative times a positive. So the answer will be, for my first term, a negative. Next step, what's 13 times 3? For the number now, we are looking at the number because the sign is already taken care of. We go to the number. What's 13 times 3? 13 times 3 is, and the grand jury says, 39. Very good. Okay. You see. Yeah. I think not that guy Kex has got a misconception there, because you see someone is saying, don't we factorize? No, guys. The statement is saying simplify the following. And now you guys need to also clarify in your heads the difference. You need to distinguish and look at the question and what it is saying. So here we are asked to simplify, not to factorize. When we factorize, we get told explicitly that factorize the following. So here we are asked to simplify, and simplify usually entails we need to apply the distributive law, especially if we can see that there is something external to a bracket, because that's multiplication. Brackets mean multiply, guys. That's what brackets mean, all right? But especially if the question is saying simplify, we do that, okay? Then after multiplying the numbers, then we go to the letter. What's x times x squared, all right? X times x squared, when we are multiplying same bases, what do? We keep the base, we add the exponents. So there's an exponent 1 that we don't see. 1 plus 2 gives us 3. So that's negative 39x to the power 3. Do you see, guys, how I've taken care of the sign, the number, the letter? Now imagine if all learners would be able to really be aware of the fact that, okay, I must first multiply the sign. Negative times a positive is negative. The number 13 times 3 is 39. The letter x times x squared is x to the power 3. If you did that consistently for each thing that you distribute, guys, you would all be amazing. So let's look. Negative 13x now needs to be distributed to negative 8x. Again, sign. Negative times a negative gives us a positive. Do you see that, guys? Then what's 13 times 8? All right. What's 13 times 8? My beautiful comment people in the comment section. 13 times 8 gives me comment section, don't fail me now. 104. Thank you so much, Kanya. All right. Then what's x times x? Because we are done now with the number. Now we are going to the letter. What's x times x? X times x is x squared. We keep the base, we add the exponents whenever we are multiplying, right? Then we take the negative 13x, we distribute it to the last term. Do you see that, guys? And again, we start with S and L. What's negative times a negative? Again, it is positive. What's 13 times 9? Okay, my people are saying 117. And then there's an X variable, and it's alone. If we multiply that X variable with the 9, we get the X. Done. Bracket means multiply. Brackets mean multiply. Brackets mean multiply. Hence, distributive law. Because whatever is external to my bracket, what combines this bracket with this 13x is the fact that we have multiply in it. Does that make sense? All right, so that's very, very important. Very, very important that we do that. Okay. Walid, you joined this live late. You see, now you're asking me questions that I've already answered. Okay. So the question 1.1.4 was saying give the coefficient of x. So if you go to the expression, okay, the x term is this one. What is the coefficient? The coefficient is what is combined to this x. All right, so what is combined to this x? What is combined to this x is the positive half. So that is the coefficient. That's why we say the coefficient of x is a half, and it is positive. Okay. All right, so let's go to 1.4.2. Okay, guys, I'm sure now you see this one as well. Negative 3x cubed. You see as well, it is combined to this 1, 2, 3 terms inside the bracket by what? By this bracket, which means what? Multiply. So once again, we have to say distributive law using S, N, L. Do you see that, guys? Distributive law using S, N, L. So let's go ahead, distribute the law using S and L. All right. So once again, we say negative times a positive. Yes, Rahoto. As always, you know, most. Negative times a positive, you should get the sign. 3 times 8, you should get the number. X cubed times x squared, you should then get the letter with its exponent. So negative times a positive gives us a negative. What's 3 times 8? That is 24. What's x cubed times x squared? When you are multiplying same bases, the law of exponent says you keep the base, you then add the exponent. So what is 3 plus 2? That gives us an exponent that is 5. You see that, guys? Thank you so much, Absence. Thank you so much, Absence Tech. Really appreciate the rose. Then we do the same thing. Slindy, thank you so much for the heart me. Guys, so generous. My goodness. Thank you. On a Sunday. Asanda, thank you. My goodness. 4 of them. Really appreciate the goodness. Okay. Then here, second term. Negative times a negative. We get a positive. Okay, so you see this thing of considering the sign, the number, and the letter, because if we do that consistently for everything, we are going to be fine. So negative times a negative is positive. We go to the number now. 3 times 7, it is 21. Then we say x cubed times x. We keep the variable whenever we are multiplying. We keep the variable and we add the exponents. You know. So what's 3 plus the exponent 1? That gives us x to the power 4. Let's be very careful there, guys, because remember, there's a 3 there. There is an exponent 1 there. So 3 plus 1 should give us x to the power 4. Very important. You keep the base. You add the exponents when you are multiplying same bases. That's law of exponents. Okay? Let's not forget that. Then the last one. 3x cubed, we distribute it to negative 6. So once again, sign negative times a negative gives us a positive. 3 times 6 gives us a 18. Then the x cubed, there's no other variable there. So the x cubed simply lands there and is combined to the 18. Okay, and if you look at these three terms, 1, 2, 3 terms, all of these three terms are unlike terms, so there's no term that can be added. That's why we leave the answer as it is. Okay, yeah. So when we are multiplying those same variable bases or letter bases, we keep the base, we add the exponents, especially if the bases are the same. See, when we multiply this variable base x to the power 3 and this variable base x to the power 2, we kept the base x and then we added the exponents. 3 plus 2 is 5. Look at this one, 3x cubed with negative 7x. For multiplication of the letter x times x, we keep the base, we then add the exponents. There's a 3, there's an invisible 1. 3 plus 1 is 4, so x to the power 4. And then for the last one, there was no variable for 6, so therefore the x cubed is simply there to stand alone with the sign and the number that we got. All right. And guys, we do not add unlike terms. There is no way that we are going to continue further. You can't add this with that. Why? Because the variable and its exponents are not the same. Okay. Yeah. So I hope we understand that. That's very important. Yes, CD. No way. You cannot add unlike terms. We only add like terms, okay? We cannot add unlike terms. So x to the power 5 is different from x to the power 4. It's different from x to the power 3. Why? Because the exponents are different. Therefore, we cannot add these. We leave them as they are. These are like, this is like trying to mix water with oil, you know? One floats from the, so water and oil, they even though you can try and mix them together so that they become a solution, they never become a solution. You know, one is less dense than the other. The oil will float on top of the water, the oil, you see. So it's the same thing. You cannot really combine these. These are unlike terms. Okay, let's look at 1.4.3. And as led or directed by our grade 8 syllabus, you'll remember that with this one, what you usually took into consideration was that whenever you have a number of terms in the numerator and there's only one in the denominator, you did something that we call you split each individual term in the numerator and you wrote it over the single denominator. Okay, so we are going to employ that method, okay, because it is a method that we learned in grade 8, which we can still apply as grade 9 learners. Okay, so there it is. I'm taking each numerator term and I'm dividing it by the single denominator. So we only do this when there are multiple number of terms in the numerator and one single term in the denominator. You can split the numerator so that you can write them under the denominator. Okay, so you write each individual term in the numerator underneath this denominator. So you can see 24x cubed y cubed over negative 8x squared y. I took the next term, negative 72xy squared over negative 28x squared y. And then I'm going to lastly write negative 56x squared y squared over negative 8x squared y. This is applied whenever you have multiple number of terms in the numerator and one. The condition is that there must be one term in the denominator and it must be a single term by that. Okay, so that's very, very important. All right, so my grade 8s and 9s, that's very, very important. Now we can go ahead and do what? Now we can go ahead and deal with each individual term by using what? We are going to divide now using S and L. Guys, do you see this? For this one, we multiplied distributive law using S and L. Now we are going to divide using S and L. Ah man, guys, yeah, I don't know if you're feeling me here. If you think S and L is not it's not the way to go, it's the way to go in mathematics. Maybe not in the movies, but in maths it is. 24x cubed y cubed divided by negative 8x squared y. Remember, this line stands for divide. Okay. Nah, I don't get it. Just vibes is like saying, nah, I don't get it. You don't get what? Just vibes. Okay. What's funny is that all of you guys that are saying you don't get it, remember, let me just let me just remind you of something that's very interesting. You guys are very funny people, eh? Okay. Remember when you added or when you dealt with addition of fractions? Remember, you never could be able to add fractions until you had a denominator that is what? That is the same. So what you usually did is you found the LCD between these two numbers. And I'm hoping all of you know what the LCD between 2 and 3 is, meaning the lowest common multiple. What is the lowest common multiple between 2 and 3? Let's see if people know. And we call it the LCD simply because we are talking about the lowest common multiple between 2 and 3 because they are in the denominator. Okay, so Noli, yeah, thank you, just vibes. Yes, 666, you guys are amazing. Okay, sorry, I don't want to infer some crazy stuff, but it is 666, isn't it? Okay, LCD is equal to 6. So what then you can do is you take this denominator and you try and fashion it so that it is like this LCD. But what do you do to 2 to get 6? You multiply 2 with 3. But what you do in the denominator, you must do where? In the numerator, so that you can form the new equivalent fraction of 1 over 2, which is what? 3 over 6. Hey, you see how nice? The equivalent fraction. This is a term that is utilized in grade 7 and in grade 8. Equivalent fractions. So the equivalent fraction of half that has the denominator 6 is 3 over 6. You see that? Then here, what do we multiply this 3 by to get 6? We would multiply it by what? By 2. But what we do in the denominator, we must do where? In the numerator. So what's the new equivalent fraction of 1 over 3 that has the denominator 6? It is 2 over 6. Do you see that, guys? So that's, now we can say it's 3 over 6 plus 2 over 6. You know, does that make sense? Now, Noli, this attitude that you have there, even if I do all of the studying and getting right answers in the test, I'm failing. Now, that has to do with something that you need to change as far as your own personal mindset. Okay, I think your mindset there is going to be the one that's going to fail you. So the maths is not failing you. And it's not that you don't understand the maths, but it's your mindset that is failing you. So we need to change that mindset, Nodi. Like this is such a predominant mindset I find in so many learners. It's a mindset that actually I wish we could work on it, you know. So Noli, what you need to do for me is you need to send me a DM. Send me a DM, will you? All right. Because now you that mindset of yours, we need to over time change it to something else, right? Yeah, we need to change that mindset to something else. Send me a DM here on TikTok. Just send me a DM. Say I am that one that basically sent the message in the comment section, and I was saying that, you know, even if I study now and get it right, the answers is I'm doing this with you, but I'm going to have a problem when I'm writing the test. I'm going to fail. Okay, we need to change that mindset, because that mindset needs to be eradicated completely and fully. And once you eradicate that mindset, you're going to be good. You're going to be good because you have the makings and the markings of a brilliant academic student in mathematics that can get phenomenal marks in the future. So we need to work on this mindset. Okay, so here, it's not a maths problem, it's a mindset problem. And that mindset problem, once you work on it, you'll be fine. Okay, so guys, sorry, let's back here. Come back here. Yeah, sorry, I don't know what's happening here. Okay, so that was 3 over 6. That's plus 2 over 6. So, guys, you see this? You see this? Look at this. We could write this as 3 plus 2 over 6. Okay, now I'm sure you guys can see what I'm trying to do here. Okay, because the thing is, when it comes to addition of fractions, you cannot add fractions until the denominator is the same. When the denominator is the same, then we can add the numerator. I hope that makes sense. But if you look at this, this is 3 plus 2 over 6. How many terms do you have in the numerator? 2. How many terms do you have in the denominator? 1. But when I can rewrite this 3 plus 2 over 6 as 3 over 6 plus 2 over 6. Do you see that these two are separate now? But look at this combined. 2 at the top or more at the top over 6 can be split into however many numbers I have in the numerator, or however many terms I have in the numerator. So I'm trying to make the point for those people that are wondering, Habo, what happened here? Why does this now say you can write this over that, one fraction, this over that still, that fraction, this over that still, that fraction? How is it that we can split this into 3 individual fractions? Okay, how is it that we can split these into 3 individual fractions? And this is the logic. If you have many terms in the numerator, whether it be 2, 3, 4, 5, 6, 7 terms, but in the numerator there's just 1, you can split this fraction into however many terms you have in the numerator. And this is the point I want to drive through, that you can split this into however many terms you have in the numerator. So because there's 1, 2, 3 terms and I have 1 term in the denominator, I can now split this into 3 individual fractions. Okay, so splitting the fraction is very important. So we split the fraction, and this is an important pivotal point. Then 2, we can now divide using SNL. All right, so now we can go ahead and divide using SNL. I'm going to divide each individual term. So when we divide, we consider the what? The sign, the number, the letter. So let's go. What's a positive divided by? This is a negative sign. So positive divided by negative, guys, gives you a negative. Because remember, whatever you do with multiplication with signs, it's the same thing you do with division with signs. So a negative divided by a negative is the same thing as a positive times a negative times a negative. So if you say a negative divided by a negative is a positive, then it's the same thing with a negative times a negative. It gives you a positive. Okay, so a positive divided by a negative is negative. Okay, then you go to the number. What's 24 divided by 8? 24 divided by 8. So since this is a fraction, guys, since this is a fraction, 24 divided by 8 gives you 3. But I'm going to deliberately write this as 3 over 1, since I'm dealing with a fraction. Okay, and then we move on to the letter. What's x cubed divided by x squared? Remember, when we are dividing same bases, what do? We keep the base, but this time around we don't add the exponents, but we do what to the exponents, guys? We subtract. So that's 3 minus 2. 3 minus 2 is 1. All right, thank you so much, Minnie. You've got it down there in the comment section. I really appreciate it. So when we are dividing same bases, we keep the base, we subtract the exponents. 3 minus 2 is 1. And obviously this 2 exponent goes to the numerator so that it can be subtracted, all right? Because the big exponent will receive the smaller exponent and subtract there in that position in the numerator. Same thing with y, 3 minus 1. So it's y to the power, what's 3 minus 1? Because this is 3, this is 1. There's an exponent 1 that we cannot see there. So 3 minus 1 gives us 2. So our first term is 3xy squared. Okay, so hopefully so far so good, we are good. Let's move on to the second fraction. We look at SNL again. What's negative divided by negative? That gives us a positive sign, because we have a negative divided by another negative, so we get a positive. What's 72 divided by 8? Okay, let me just await people to answer. 72 divided by 8. Okay, it's 9. Thank you so much, guys. It's 9, definitely. Right. Then we have an x in the numerator. Okay, so we are going to write here 9, but we're going to write 9 over 1. There's a reason why you're writing 9 over 1. Okay, we just write 9 over 1 because it's a fraction. You see here I wrote 3 over 1, but eventually I'm going to write my final answer with obviously things isolated. So let's look at this. This is x, and x squared. No, sorry, this is not x squared. It's x squared. So it's x squared, we have x. So what do we do here? All right, if you remember in grade 8, we usually sent the smallest exponent to where the variable is the biggest exponent. So here we have the exponent 2, all right? So that's to the power 1, that's to the power 2. So we can say x to the power 2 minus 1 in the denominator, okay? In the denominator. And it's because of things like this that I retain the fraction, because you see now this variable x to the power 2 minus 1, that means I'm going to have an x variable in the denominator. Then let's go to y to the power 2 in the numerator, y to the power 1 in the denominator. So here we are going to say y to the power 2 minus 1, which is 1. So this y is in the numerator, whereas this x is in the denominator. Okay, so I hope you understand that. Then let's move on to the next one. Negative divided by negative is also positive. Very positive. What's 56 divided by 8, guys? It is 7. Okay, it is 7. And then what's x to the power 2 divided by x to the power 2? Obviously x to the power 2 divided by x to the power 2 gives us x to the power 0, all right? Which we know x to the power 0 is 1, but we will sort that out later. We'll write the final answer. Then y squared divided by y, that's y to the power 2 minus 1 in the numerator, which gives us y. Okay, so finally, all right, I'm just going to finalize the answer. We have negative 3xy squared plus 9y over x plus 7y. This will be our final answer that we get for our expression. Okay, negative 3xy squared plus 9y over x plus 7y. Okay, so here I simply utilized a method that in grade 8 was available to us, and that was, if you have two variables, numerator and the denominator, that are the same, you can actually take the exponent that is the smallest, take it to the denominator and subtract from the biggest exponent in the denominator. All right, this was all in the name of trying to avoid negative exponents as grade 8 learners, because in grade 8 we don't learn about negative exponents. So what we had learned as a rule in grade 8 was that if ever you have a variable with a big exponent and then there's a variable with a small exponent, the subtraction because of division of same bases will happen where the exponent is the biggest. The subtraction will happen where the exponent is the biggest. So that's what we did in grade 8. But as grade 9 learners, maybe another grade 9 learner here in the live would have basically done this, and I have no problem with doing that. Okay, maybe a learner would have said, it's 9 x to the power 1 minus 2 y to the power 2 minus 1 plus that 7x to the power 0y. Now, obviously, with the knowledge that we have in grade 9, we learned in grade 9 about negative exponents. So, because we know what we know about negative exponents in grade 9, okay, you would have written your answer in this way, right? But you know that you can't leave your answer having negative exponents. So finally, you would have concluded and said the answer is 9. Remember that when x has a negative exponent, in the numerator, you must send that same variable into the denominator with that same exponent, with no longer a negative exponent, but a positive one. But it is in the denominator now. So it must change position from the numerator to the denominator raised with a positive exponent, not a negative exponent. And that basically concludes your final answer. So yes, as grade 9 learners, we know that we can actually subtract and get a negative exponent. And then please, we make sure that our exponents don't remain negative. Okay, and how do we make sure that we actually write our answer having a positive exponent? If the relationship between the combined variables and coefficient is multiply, then you send that variable to the denominator, the exponent changes to positive, and then that's basically how you would write your answer. So this, okay, grade 8, and then obviously grade 9, you could have definitely written your answer that way. Okay. So yes, please, if you did not get this answer, please go ahead and double check your steps. It's very important to do so. Yeah, definitely important to do so. All right. So guys, I'm gonna hold it right here. Okay, this I think was a fruitful session, right? Like I said, this is just me revising some grade 9 because remember, exams are fast approaching. I think you guys have no less than a little bit more than between 25 to 30 days until you guys write, especially grade 9s. If you guys are writing at the beginning of June, let's say maybe on the 6th of June or the 9th of June or whatever that date is when you are writing your papers as grade 9s, you need to now start having a plan in place, a very watertight, solid plan on how you will actually practice the work that you have done. Remember, from term 1 already, you need to be able to make sure that the term 1 work that you guys covered, your numbers, real numbers, you need to know your prime numbers, your composite numbers, how to find the common factor, highest common factor between numbers, the lowest common multiple, how to identify your exponents. They need to be sorted. You need to make sure that you are able to simplify, numerical questions such as this, applying BODMAS and BEDMAS, right? We need to be able to do all of these. Answering statement type questions, knowing what divisible means, knowing what a multiplicative inverse is, an additive inverse is, being able to apply the properties, the number properties, the whole number properties that you learned. Equations, grade 8 that you learned, linear equations. You need to know how to solve equations. We need to know how to do mini questions, exponential equations, and all sorts. Expressions, simplifying expressions. These are very critical and very important. Now, word problems, also very, very important. Word problems, because equations sometimes have word problems. Your number patterns, guys, they need to come back. You need to know how to be able to answer questions having your number pattern type questions. Your method, your financial mathematics, your financial method, simple interest, compound interest, higher purchase agreements. You need to know how to answer those types of questions. They are very important. Financial maths, your commission, VAT, increase, decrease, numbers, guys, numbers, rational numbers, non-real numbers, undefined numbers. Be able to identify those, dividing quantities in a ratio, decreasing certain quantities in a given ratio. Exponents, guys, exponents, galore. Fractions, addition, subtraction, multiplication of fractions, very important. Financial maths, as I had explained, guys, compound and so forth. Those are very critical, very, very critical stuff that you need to know there. Factorization. Some of you may be busy with that at school at the moment, but there's highest common factor factorization, difference of two squares, grouping, common brackets, common brackets, trinomial factorization. Okay, that's coming up. And then last but not least, simplification of fractions, where you have to apply factorization in the midst of the simplification, because there's those types of questions where division is concerned. And you can see here there's 2 terms in the numerator, 2 terms in the denominator, unlike the question that we had looked at where there was just 1 term in the denominator. Now you have 2 or 3 terms in the numerator and denominator. What do we do there? That's where factorization has to be factored in. So we're looking at multiplication of algebraic expressions, division of algebraic expressions, and of course addition of algebraic expressions, exponential equations, and more and more and more. So guys, with those words given to you so boldly from my mouth to yours, grade 9s, remember, you grade 9s are very critical people, because your decision to do pure maths will come that much more as you see yourself being confident and fluent in your grade 9 mathematics. I believe that the grade 9 mathematics can really lay a solid foundation for most of you to have the confidence to do grade 10 mathematics. And we need more people that can actually sign up and subscribe to the grade 10 maths, guys. But you need to have this plan in place. Like I said, you need to make sure that you are practicing a bit every day. Recall some of the term 1 work that you've done. Even the test paper that you wrote in March, right? You need to be someone now who's pulling out that test paper. You need to put it before you. You need to make sure that you ask even your teacher to maybe possibly give you your paper that you wrote, and you need to be able to see the mistakes that you made during that control test that you wrote, and be able to close the gaps that you may have of the content that you did in term 1. Because remember, your June paper will have both term 1 and term 2 work. So you need to make sure that you are practicing and you are doing your part. Guys, with those words and more, let me love and leave you. I hope you guys had a fruitful session. That more than anything else, you have the heart now to sort of like, go do the most, So I will continue with this specific PDF that I showed you. I will be continuing with it. I'll be using it for the revision sessions that I'll be holding here on TikTok. So I see some of you are requesting the PDF. You want it for yourself so that you can practice. But guys, this is the same PDF I'll be using and utilizing to help you guys revise here on TikTok. And then I'll be posting some of the sessions as I do them and cover them onto my YouTube channel. So you can always check out what is covered there and so forth. And I'm banking on tomorrow, let's say at 7 p.m. I would have a similar session for the grade 9s. We'll pick up from where I left off and we'll cover the rest of this revision for June exams. Thank you so much for joining in. It was really good. And thank you for those who gifted so freely and generously. I really appreciate that. It means a lot, obviously, just the token of appreciation there. So thank you so much. The heart meals, the roses. Thank you so much. Have a good night, and please enjoy school tomorrow. Enjoy the maths more particularly. And have a good one. Have a good week, guys. Thank you so much. Lots of love from Maths is a Game. We're playing all the time. Maths is a game. It's fun. Just go for it and do the most. Thank you so much. Cheers. Goodbye. Night.